Alright, so today in physics we are going to use this square and indirect measurement to find out the area of an unknown object, of an unknown surface. So what we know right now is that we have this square, and it is precisely 20 centimeters by 20 centimeters, because I have used this handy-dandy yardstick from the Super Fun Zone to measure it. So the question is, though, while we know the proportions of this square precisely, what we do not know is the proportions of the circle, mostly because I just drew it without actually measuring it. What we do want to find out is what is the area of this circle. Now, as you can see, it's not perfectly circular. I'm going to erase it here to make it look at least a little nicer. So it would be very hard to measure with a yardstick from the handy-dandy Fun Time, because it's not actually a perfect circle. So instead what we're going to use indirect measurement based on random distribution with these here extra X markers to try and figure out what the area of this circular shape is within this perfect square. So the basic idea is if we drop these markers randomly, then they'll leave dots on this here surface, and for a dot that is in the square, you can measure how many dots are in the square, how many are in the shape, and then based on the proportions of how many are in the object overall, how many are actually in this shape, we can figure out what this area is in proportion to the already known area. So what we're going to do is we're just going to take these 4 expo markers, we're going to cap them, and then by just kind of holding them above the area, we're going to draw them so that they leave dots on the in the zone, hopefully, and we'll use randomly to determine what the area is in here based on the area over here. So as you can see from this first one, what we have so far are 3 dots already. One of the markers didn't land that well, but the idea is we're going to do this a number of times to figure the random proportion out. So we'll just keep dropping them. So you can see we've dropped more, but what we have is we have some dots inside. You can see 4 there. You can see 1, 2, 3 outside, and you can see that 2 that are outside the shape completely. So already we're going to disregard those because they're not actually in the shape with the area that we know of. We can't really use them, but we can definitely use these other ones. So we'll just do this a number of times. And the idea is to keep peppering the shape with dots. So eventually, we'll have enough to do our calculations and figure out what is going on in the square and how big this shape is. Now, it's important for a very large sample size when doing experiments like this. When we first dropped just the first 4, there were like 3 dots right within the shape, so if we had just based our measurements on that, then our calculation would have told us that the area of the green is the same as the area as the huge shape. But obviously you can see just from looking that that's true, so you do many more tests until eventually you have enough. So I'm just going to, I don't know, we've dropped many times now. I'm just going to count to see how many are in the square if we have enough, and we'll actually begin. Alright, so after some quick counting, I can see that we actually that we've only got 50 dots in the zone so far, and I'd like us to get up to 100. We have a few minutes here, so we'll see if we can get there, or at least we'll keep dropping the things. So the whole idea of indirect measurement is really useful when you have the area of a known substance or surface, but it's really hard to measure the one. So this, for example, is how they measure the radius of an atom, because you can take a known area and then you can fill it with a certain number of atoms, and then you can fire particles at it, and then based on how many particles land in the zone that you've marked out and how many kind of bounce off the radius of the atom and the electron cloud around the atom, then you can figure out the size of the radius of the atom. So we're basically doing the same thing here, but of course without atoms and other cool, expensive scientific equipment. We're just using expo markers and this white box board. But the concept still works, and so we'll be able to demonstrate some cool things just with this. So we'll keep dropping them here. So you're in a lot of spots. And so scientists use this all the time to try and figure out stuff like that, or what the size of an atom is, or do you really have any irregular shape? Because while it's pretty easy to measure, say, the size of certain shapes with, size like polygons are pretty easy to measure, a perfect circle or perfect ellipses kind of thing, or area under a curve or thing. It's much harder when you don't have equations or whatever you're measuring or anything like that. So this is just a really good way to do all of that. So done a lot more. Jumping here, and I'm just going to count to see where we're at. Alright, so far we've got 85 in the square, but outside the green area, and we have 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and we have the third in. So we can use that, that's enough. So just totaling this up here, we have 105 total dots. And now we know the area, and now the area of the square is equal to 400 centimeters squared, because we already figured that out, but now the area of what I'll call the circle, tentatively, is unknown. So what we can say now is we can just set up a proportion. We can just set up a little proportion, and we can say